All right. Thanks for having me. If it's two things I'm passionate about, it's chemistry and wine. And I have to start this by saying I'm nowhere near an expert on wine chemistry in particular. Actually, my background is synthetic organic chemistry, but more in medicinal chemistry, not much in terms of wine. But because I'm a home winemaker, I've been very fascinated with what takes place in wine and all the aspects of wine that is under our control and the things that are not under our control. And when we think about what is in wine and the chemistry that goes on in wine, you would need a whole year of a course to really go through all of it. So I'm just going to touch on some of the aspects of the things that might be important for how we make wine, how we grow grapes, and how the chemistry profiles of wine can change depending on what we do. So what is wine? That's where we should really start, right? The legal definition is a beverage made from grapes or other fruit that has an alcohol content between 0.5 and 24%. And is for non-industrial use. So if you're a commercial winemaker, you know that. Those are the parameters that you have to stick with for wine. But in terms of really what is wine and what's the makeup of wine, we have to know a little bit about how wine is made and how it's manipulated at each stage of the game. So we all know how wine is made here, right? We have a lot of winemakers in the room. We grow grapes. We crush them, we press that juice away from the skins, or we ferment with the skins, depending on the style of wine we want to make. We add yeast to that must. Fermentation converts sugar to alcohol. That's the key chemical reaction we're all interested in. We can do secondary fermentation, that's malolactic fermentation. I'll mention a little bit about that. And then we have to let the wine clear after fermentation, and we often age it in barrels, depending again on the style of wine and what we want to impart in wine. So every step along the way, from before buds break to putting it in a bottle, we affect the chemistry of what's in that wine. And we can do that to a disadvantage, or we can do that to an advantage. And so it's important to understand, at least appreciate some of the aspects of what's going on. If you look at just the gross profile of a grape, okay, before we make wine out of it, it's about 70 to 85% water. And the rest of it mostly is sugars. And those are really important because we have a liquid beverage, and we want the sugar to be converted into alcohol. But it's all those thousands of other tiny amounts of chemicals in there that really make the wine. The flavors, the colors, the aromas, whether a wine is flawed or not depends on some of these small, the presence of compounds in very small amounts. The acids are very important for the flavor profile and the stability of wine, the aging potential, and the color of the wine. So the acids are also very important. If you look at a grape isn't just all uniform from middle to the outside. We know that the grape has different components. We have the skin of the grape, which is where a lot of the coloring agents are. Actually, the flesh of the grape is colorless in most cases. Not that there aren't colored grapes, but most of the grapes we use for winemaking are colorless. That's where most of the sugars, acids, and water is contained. Most of the other components of the chemical profile of grapes are in the skins and the seeds and the stems. And the seeds and the stems are usually the ones which have the more bitter tasting components of wine. And so how we crush the grape, we want to do it gently so that we don't break those seeds apart. De-stemming can be important to remove some of those off flavors of those tannins that are contained in there. How much time we leave it on the skin, Mark was alluding to this a little bit in terms of the specific grapes might have aromas and flavors that are not that desirable, but we still want color extraction. We want some of the chemical components that cause those colors to come out. So it's always a balance in how long you let something be exposed to those skins. The bladder presses help a lot with gently pressing to avoid breaking the seeds, and so that's been beneficial for avoiding some of the harsh tastes from the seeds. Okay, but this is the key money-making chemical reaction, right? We have this juice from the grape, and we add yeast to it, and all of the sugars in there, not all of the sugars, but the sugars that are available for fermenting are converted into alcohol and carbon dioxide. That's the moneymaker. But this is a very complicated biochemical process. The yeasts are living. They have the ability to eat this sugar, but if you step by step follow the sugar molecule as it's being converted into alcohol and carbon dioxide, there's at least 12 different enzymatic steps involved. Breaking down that sugar and taking it apart so that you get alcohol in the end. And I'm not going to go through all that. I'm not a biochemist. I don't actually know all of those specific steps. But we can talk about some of these sugars. Winemakers refer to the sugar level in grapes as the degree of Brix, which is essentially the same as the percent. So 1 degree Brix is 1% by weight of sugar in that solution. And 1% sugar, or 1 Brix, upon fermentation will produce about 0.55% ethanol by weight. And so you actually have a less percent alcohol than your percent sugar because of the way the molecules breaks apart and the weights of ethanol versus your starting sugar. In grapes, the 2 most common sugars are glucose and fructose. These are what we refer to as the fermentable sugars. The amounts in grapes can vary depending on the ripeness level of the grape. And that has a consequence actually on the wine making, because these sugars are not metabolized by the yeast at the same rates, and they have different taste profiles, the different sweetness levels. And along with these 2 grape sugars, there are some other sugars that could be present in wines, and they are not fermented by the yeasts. They're not metabolized by the yeasts. These are things like arabinose and rhamnose and xylose. They can be present, and they're maintained throughout, and they're still present after fermentation. And usually they're in very tiny amounts. So about 0.1% might be some of these other kinds of sugars that are present. If they're about 0.2% or higher, then we have the ability to actually taste the sweetness of these. It can affect the overall profile of the taste of the wine. And I don't know, I'm not an expert on how much different types of grapes produce these. It may be that the varieties of grapes produce different amounts. I would suspect that to be the case. But some of these can be introduced actually during barrel aging, because some of the glycosides in the wood themselves can be broken down while the wine is being aged and then be drawn into the wine. And so some of these non-fermentable sugars, you can actually add sweetness potentially in some wines that are aged in oak. So something to keep in mind. But these fermentable sugars, so at harvest time, when we want to harvest grapes, the amount of glucose and fructose are about equal. So we have about a 50-50 mixture of glucose and fructose. As the grapes become more and more ripe, the level of glucose goes down and fructose goes up. And that has some consequences because fructose is about twice as sweet on our taste buds as glucose is. So it tastes sweeter, and it ferments slower. Glucose, if you have both of these sugars present, glucose is fermented away first, and then the fructose is fermented by the yeast. So if you have a fermentation which gets stuck, not all the sugar is consumed, it may be you have now higher percentages of fructose, and it'll taste sweeter even if the sugar percentage isn't as high as it was before. Okay, well, let's talk a little bit about wine color. Wine color is also a very complicated aspect of wine. White wines and red wines can have varying shades of colors. Some of this is due to the chemical components in the wine and in the skins, and some of this is due to aging. So if you look at this profile from in the white wines from sort of green through straws, golds, yellows, ambers, and browns. That's actually looking at the aging of a wine as the color components get oxidized. You notice also for red wines, generally they start out on the purple-red end when they're young, and as they oxidize with air over time, they turn brown and bricky. So the chemical components that make up the colors are not stable over long periods of time with air. They do brown. But the colors are also affected by the pH of the wine. They're affected by the concentrations of the chemical components that are colored. And the coloring agents in these wines are very much related to the tannins. So we should talk a little bit about tannins. This word is used a lot. Does anyone know where the word tannins actually came from? When was it first used? Well, tannins was a term used to refer to wood tannins that were used to tan leather. So they would tan animal hides with these tannins from wood. And so that's why we call them tannins. But it's a word just to describe a lot of different molecules. It's not just one molecule. It's a whole family of molecules which we call polyphenols. And not all polyphenol is the same. Tannins tend to aggregate together and form larger molecules, or smaller, or they can be broken apart and form smaller molecules. And those affect a lot of aspects of the wine. The ability to age, so the components of these polyphenols are antioxidants. So if oxygen does get into your wine, they can react with tannins first before reacting with other things in your wine that you want to keep there. Some of them are very astringent and bitter tasting. Those are mostly, as I said, found in the skins and seeds and stems. And two main kinds found in grapes are referred to, you might have heard these terms, hydrolyzable tannins or non-hydrolyzable or condensed tannins. They are slightly different. So if you take a look at some of these molecules, hydrolyzable tannins are polyphenolic molecules such as gallic acid, ellagic acid, which are connected to a sugar core. And these sugar cores, these can be broken apart in the acidic media of the wine as well. And so the chemical reaction that takes place over time, these tannins tend to come apart. These polyphenolic compounds, some of them are very beneficial because for our health, they're antioxidants. Condensed tannins are tannins which are polymers of these flavonols and flavonomes. And these tend to be the astringent ones depending on how large the polymers are. So as single molecules or small molecules, these things are very bitter tasting. And we know that as we age wine, the bitterness smooths out over time, right? What's happening is that these molecules are connecting with each other and forming larger polymers, and those either drop out of the wine or we no longer taste them as the bitter sensation on our tongue because the molecules don't fit into those taste receptors. And so over time, that polymerization is what mellows the wine. And those are still there to protect the wine as well. So wines, it's kind of also a balance between the bitterness and astringency and the protective qualities of these things in the wine. Okay, but one of the components which is very similar to those tannins or polyphenols are what we call anthocyanins. And anthocyanins are what gives rise to the red color of wine. These molecules are polyphenolic, as are a lot of the thousands of molecules in wine, found mostly in the skins, and they're water soluble. I don't know if you've ever noticed, if you have like your used wine glass with a little bit of red wine in the bottom, and you might have tried to rinse it out in the sink and you saw it turn blue. Has anyone seen that? Yes. Why does it turn blue? Any idea? Yeah, the pH is higher in the water. The wine is an acidic media, and what's happening is that these anthocyanins, the color of them is related to the pH of what it's in. So if you go towards a more alkaline pH, these will turn blue. And you see that when you rinse those glasses. Last time I talked about this, I actually had a little chemistry demonstration to show. I added some sodium hydroxide to some wine and it turned from red to blue. It was kind of cool. These are antioxidants. They also can polymerize with tannins, so colors can fade over time because of that. But they are brightly colored, and we're happy to have them because they look really nice in their glass. Another coloring component is found in wine, which is called quercetin. Actually, it's a yellow-colored component. It's not in high quantities generally, but it is an antioxidant, so it has health benefits, potentially anti-inflammation in particular. So it's not a bad thing to have in wine. It is produced in the berries, especially the ones that are exposed to sun. Those tend to have higher concentrations of this particular coloring component. So what about the flavors and aromas? So we talked about color, we talked about the main fermentation reaction, but colors go along with the flavors and aromas, and that's what we're really after. Also a very, very complicated business. You might have seen the aroma and flavor chart, right? And there's lots of ways that we describe wine, from chemical flavors of sulfur and petroleum to fruity flavors, tropical fruits, herbaceous, asparagus, bell pepper, right? The wine snobs always describe, oh, I get a little hint of cut green pepper, and things like that. Many things go into these flavor and aroma profiles. Many, many things. And some of them are not all bad, some are not all good. And some are flaws of the winemaking, and some are produced through chemical reactions while the wine is sitting in the bottle. So things are happening all the time. There are lists and lists and lists of specific chemicals that have been identified associated with flavors and aromas in wine. Here's just a few of them. For example, herbaceous, grassy, bell pepper, asparagus. These types of aromas and flavors are associated with methoxypyrazines, found in Sauvignon Blancs and Cabernet Sauvignon in particular. Some of the floral aromatics that we see in a Riesling or Gewürztraminer due to monoterpenes. Some grape varieties have spicy notes, vanilla notes. Vanilla also can come from the wood of oak. That's another way to impart vanilla flavors. And then Mark was just talking about hydrogen sulfide. Hydrogen sulfide, over time, and if you don't catch it early and aerate it, hydrogen sulfide can easily be dissipated from wine. But once it starts binding to other components and making other mercaptans, forming bonds to other kinds of atoms besides hydrogen, then they're not easily dissipated. And that's where you have the problem. They smell very, very strong. Rotten eggs, rotten cabbage, sometimes a rubber smell, or cat urine has been described. And that's really a flaw in the wine. Although this is usually the winemaking flaw because there's not enough yeast nutrient present during fermentation. However, some grapes actually and some yeasts produce more of this. So you could do all you can do to knock this down, but you might still have some of these notes in the wine as well. And some people ask the question, is that favorable or is it flawed? And there's a wine actually that sort of capitalized on this. I don't know if anyone has ever had this wine. There's a Sauvignon Blanc from New Zealand called Cat's Pee on a Gooseberry Bush, because that describes the sort of aromas in this Sauvignon Blanc. Now, the cat urine smell in here is very subtle, and so at that level, maybe it's a pleasant thing, I don't know. But they market it, you know, if you have a wine that has something wrong with it, maybe you could market it in a unique way. Yes?
Rick, can I make a comment?
Sure.
The winemaking process, it's very important that you go through lots of winemaking, like every day, initially, you smell it.
Oh, yes.
Immediately. And if you catch it right, then just a shot of gas, a little nitrogen, the next day. So it's very important every day to smell that wine. No doubt when that happens. Right? So.
Yes. A lot of the flavors and aromas in wine can develop through fermentation, after fermentation, during aging, and a lot of it is associated with forming volatile esters. So in chemistry terms, an ester is a molecule produced from the combination of a carboxylic acid and an alcohol. Both are present in wines. Different ones are present in wines depending on how it was grown and produced. During fermentation, the formation of these things is dependent on highly on the yeast that you're using. So different yeast strains impart different kinds of flavors and aromas because they're producing different kinds of acids and alcohols during the fermentation as byproducts of what they're doing. So yeast doesn't just eat sugar. Yeasts are living, complex biochemical systems that are producing all kinds of components. This process of forming volatile esters, which are often fruity and things like that, is a reversible process, especially in the acidic situation that we have in wine. So the formation of esters can be done, but also breaking them apart can be done. Over time, as the chemistry in the bottle changes, your flavors will change. And that's something to keep in mind. If you have some really bright, fruity flavors in your wine when you first bottle it, 5 years down the road, they're going to be completely different. Some of these are good and some are bad. So in wine, we're producing ethanol, which is a 2-carbon alcohol. And we also have oxidation products of ethanol, which is acetic acid. Mark talked about that as well. That combines to form ethyl acetate, which is what's in nail polish remover. Okay, so that would smell like an industrial solvent, and you might have smelled that. Acids that have longer chains, some alcohols that have longer carbon chains, they tend to have aromas of petroleum or fusel oil. So that can also be undesirable in the wine. But often esters are very aromatic. This one in particular smells like bananas. Here's one that smells like roses, so that might be imparting floral notes to a wine. Monoethyl succinate is a combination of the ethanol plus succinic acid. This is a really good one to have because it's a very fruity aromas. And that's often found in wine. And there are literally hundreds of different kinds of combinations of acids and alcohols that combine together in wine. The flavor profile is a really complicated combination of many, many, many molecules. Okay, what about acidity? Wine is an acidic media, as we know. pH generally about 3 to 3.5. It can be lower than that. If it's higher than that, that's not that good for the wine. But where does that rank among other kinds of things that we know? Well, vinegar, distilled vinegar actually comes close to the pH of wine. About 2.4 to 3 is a typical 5% distilled vinegar. Coca-Cola is about as acidic as wine. And so wine lies somewhere around here. Tomato juice is less acidic. Coffee, milk, neutral water is at a pH of 7. So gives you some idea about where that acid level actually sits in terms of strength of acid in wine. And the acids in the wine. Acid is really important. It provides balance. It provides sharpness to the wine. If you lack acid, you taste a wine lacking acid, which is usually not the problem with things grown in this climate. But they taste dull and flabby. Here we have the opposite problem in that they are too sharp and too bright. But it is important to have the right acid level because yeasts need to have a certain level of acid to propagate properly. The acid content helps inhibit harmful bacteria. As a matter of fact, Mark was talking about sanitation, but I have to say, wine is thousands and thousands of years old, right? They didn't have sanitation back then. Now, it's spoiled easily because of oxidation, but nothing harmful to humans would live in it. Harmful bacteria doesn't live in wine. Because the pH is low enough and the alcohol level is at the right content, only bacteria that is not really harmful to us can live in it. The acid level also affects the color, as I talked about with these anthocyanins. So it has to be acidic pH for that to be red color and not blue. Two main acids from the grapes are tartaric and malic. You see here the structures of tartaric and malic. It crystallizes out in those glass shards Mark was talking about. That's potassium bitartrate crystals, also called cream of tartar. So people industrially use these for those byproducts. You can see them crusted here. You might have seen these, what often referred to as wine diamonds. I like that term better than glass shards. Wine diamonds forming on the cork. Crystallization of chemical components usually requires some kind of a rough surface to start growing on. And that's why you often see these things crusting on corks in the bottle. Cold stabilization can help precipitate out tartaric acid from your wine. This is good because you can actually lower the acidity by cold stabilization. Adding a little bit of potassium bitartrate solid actually seeds that and allows those crystals to grow there. And that's why a little bit of that is sometimes added when you're cold stabilizing, because that allows then, it's kind of like a catalyst for the tartrate crystals to grow when it's under cold stabilization. Citric acid. Citric acid is an acid which has 3 acidic groups. So tartaric acid and malic acid have 2 acidic groups on it. Citric acid has 3 acidic groups. And so it's a brighter acid, brighter tasting acid. Sometimes it's added to brighten up the wines. But frankly, I don't recommend adding citric acid to wine because there are problems with citric acid, which I'll get to in a few minutes. I was going to say something else and I just forgot. Well, I'll come back to it. Acid blend. Acid blend has citric acid. I'm not a fan of acid blend. I think if you're going to add acid to your wine, add tartaric acid, not acid blend. Malolactic fermentation is not a yeast fermentation. It's actually a bacteria which does this fermentation. And this is a process which takes malic acid and converts it to lactic acid. So this particular, actually it's a family of bacteria called lactic acid bacteria. It basically is chopping off one of these acid groups and forming lactic acid and carbon dioxide. A result is you change the flavor profile and you change the overall acidity of the wine because you've reduced the acidity a little bit by losing one of these groups. The flavor of malic acid, since it has 2 acid groups, is sharper, more acidic. This is more rich and buttery. That gives the buttery flavors to Chardonnay. If you know, Chardonnay is usually put through malolactic fermentation. Most red wines are put through malolactic fermentation. I would say with the high acid levels around here, hopefully the malic acid is high enough that you can do ML fermentation and reduce the acid levels. That's another way to do this.
And when is that done?
Huh?
When is that
That depends. I know that it can be done during fermentation, primary fermentation itself, or sometimes done afterwards. And after the fermentation of the sugars is done, then you can add the lactic acid bacteria to get that going. And if you age, like in the wine industry, they're aging their red wines in barrels, and those barrels already have naturally that lactic acid bacteria impregnated in that wood because they've done that. So after they ferment it and they put it in the barrels, it's undergoing that secondary fermentation in the barrels. Yes?
Greg, what would be the result of doing malolactic fermentation on apple?
Oh boy, yeah, that's a good question. Since it's all malic acid, I don't know. I'm sure it's been done. I don't know that the outcome would be pleasant. Because you can overdo the rich, buttery flavors of the lactic acid. But has anyone done that experiment? Someone should do that experiment.
Someone should do that experiment, we taste it next year, the difference of what it is.
What is typically the percentage of malic versus tartaric in grapes? I don't even actually know that. Is it about 30%
It's
malic?
about 30, yeah.
Yeah, that's what I thought. So I think if you get too much, then you might have strange flavors. I don't know. It'd be interesting to try. Yes.
If you do want to do an ML fermentation, if you look at Scott Labs or one of the other providers, some ML bacteria work better if done right up front.
Yes.
Some work better if done later. So
That's
it's
right.
important to know where you want to inject that into.
Exactly. And I know it can change the flavor profiles in the end too, when you do that.
There is a big trend in California right now to do cold at the beginning, right during the fermentation process, with the bacteria in there, and then by the time it ferments out at 7 days, the primary is
Already gone done, yeah.
fermentation.
Yes.
Well, and a few of these other guys now are starting to develop yeasts that will lower acidity as well, so you don't actually have to do malolactic fermentation as long as it's not too out of control.
Right. Well, you have to be careful with malolactic fermentation. It can produce some off flavors. For example, and this is one of the reasons why I recommend never using citric acid, and particularly if you're going to do malolactic fermentation, don't add any citric acid until after that's done. Because malolactic fermentation, those lactic acid bacteria do convert citric acid to diacetyl, and that can give off flavors to your wine. The other acids are not broken apart by the lactic acid bacteria, but citric acid is, and so that's one problem with that. There are other acids in wine. Acetic acid is produced by oxidation of the ethanol. Usually that's controlled or affected by the presence of Acetobacter bacteria, as Mark was talking about, and also the oxygen. So if you don't expose your wine to oxygen, you don't get that oxidation to happen. Yeasts and bacteria can produce other kinds of acids. One is butyric acid. Butyric acid has a rancid smell and not that good. Fortunately, it's usually not that much of a problem in wine, but it can be produced by certain bacteria. That's why you want to try to control bacteria as much as possible with sulfite. Sorbic acid is used in the form of potassium sorbate to prevent yeast growth. And some aspects of sorbic acid I should mention here. It doesn't kill yeast. It prevents yeast from reproducing. So if you are stabilizing your wine with sorbate to prevent re-fermentation, if you haven't done that at a point where you've gotten rid of as much yeast cells as possible, you can still have fermentation present, because if you haven't let it find enough, so you've dropped out most of the yeast, then it won't kill what's already alive. It'll only prevent it from reproducing. It'll eventually die out, but if you have enough concentration of yeast cells in there, when you try to stabilize it, you can still have some fermentation going on. This is also a problem, and it's due to the MLF fermentation, which produces the geranium smells, not necessarily the yeast. It's that lactic acid bacteria converts sorbate to those awful geranium smells, and that's also a fault of the wine. Succinic acids are good. They lead to some of those fruity esters, and that's also present. Yeasts can produce this, particularly if you have enough yeast nutrient. And so sometimes if you don't get enough fruity profiles in your wine after fermentation, it may be also a sign that there wasn't enough nutrients for the yeast. And I just want to talk a little bit about carbon dioxide. Carbon dioxide is produced during fermentation, and carbon dioxide binds with water to form carbonic acid. It's a reversible process. Carbon dioxide is a gas that's dissolved in the wine after fermentation, and it takes some time for that gas to evolve out of there. You can degas it, you can stir it, some people even use a little bit of vacuum to help pull the gas out of the wine. But some of it is tied up in carbonic acid, and it takes some time as this carbon dioxide is gassing out of the wine for this equilibrium to shift this carbonic acid over. So it's important when you're doing your acid measurements that you thoroughly degas and give time for that sample, if you have carbon dioxide in there, that you get rid of all that carbon dioxide, because that can alter the measurements that you have for your pH and your TA. What about barrels? Barrels, a complicated aspect of winemaking. They were first used because those were the storage vessels. And then it was found that barrels can impart good qualities to a wine in some cases. Most red wines and some white wines, generally in the industry, spend some time in oak barrels. We have, when we're doing home winemaking or smaller operations, there are other ways to impart oak with oak chips and oak dust and oak staves and things like this. So what is the oak doing? Well, the barrel is doing several things. For the chemistry of wine, it's really introducing more chemical components and filtering some out from your wine. There's also an aspect which you don't get with oak chip additives, but you get in a barrel, is there is some oxidation as well as air breathes through that wood. But let's talk about what the oak is imparting. American oak and French oak are the two main oaks used for winemaking. They give different profiles to the wine. American oak has more lactones in it, gives stronger aromas and some of those vanilla flavors. French oak is a little bit softer. You get wood tannins extracted. Those are softer, silkier tannins from French oak than from American oak. And some of the lignans, and as I said, sometimes they can increase some of the non-fermentable sugars and give a little bit of sweetness. The differences between American oak and French oak, partly because the trees are grown in different places, but also how those trees are processed. How the barrels are made changes how it affects the wine. So for American oak, the oak pieces to make the barrel are sawn. Okay? And that actually rips apart the cells and allows more extraction of some of the components. That's why American oak is typically imparts stronger flavors to a wine. French oak is not usually sawn apart, it's split. And so that splitting process of the wood tends to keep more of the cells of the wood intact, so you don't get as much of that extraction. And then there's lots of control one has over how that oak is impacting your wine. How much you toast it changes the profile. It can be lightly toasted or heavily toasted. If it's charred really dark, then it can actually extract color out of your wine. I mean, if you think about charcoal, charcoal is very good at filtering out color. And if you're making charcoal in your wood barrel, then it's holding on to some of those color molecules. But produces smoky aromas. Sometimes I find a Pinot Noir which is way too, it tastes like you pulled a piece of wood out of the fireplace. And that's too much for me. I don't particularly care for that, but some people do. You also get different flavors, vanillas, coconuts, and things like that. So that toasting of the oak is very important for those types of qualities in the wine. And corks. Corks, well, corks have been a big problem in the wine industry. I think a lot of those problems are being solved now. It comes from a tree. It's essentially the bark of a tree, the inner bark of a tree. Almost all of it comes from Portugal and Spain. And cork taint and oxidation are the two main problems. Corks are a natural material, and it's not impervious to air. So we talked a little bit earlier about how air can slowly breathe through a cork. And that can be good for aging a wine, helping smooth out tannins. A little bit of air helps to react with those tannins. But too much air will hurt your wine. And cork taint, if the corks are tainted, that's also a problem. And they don't last forever. Corks degrade over time. Screw caps will last forever. Well, actually I don't know how long that plastic seal will last, but a lot more forever than corks will. This is a 1964 Rioja. I actually had the pleasure of having a friend who had this and opened it a couple years ago. And the cork was very interesting. That's when we took the foil off the top. You can see, very, very brown. When you pulled the cork out, it broke. Not surprising. It was a 40-year-old cork, almost a 50-year-old cork. It broke, although I was surprised it was very much still intact, which was a good thing. But clearly very brittle, and things were very dark. And if you take a look at the wine shows its age. That brown color is from oxidation, so clearly air had gone through that cork over those 40 years. And it didn't taste like fruit anymore, I'll tell you that. It was still wine, but it didn't taste like fruit. But you can see that brown color. Actually, the people who are cellaring wines for a very long time that are stored in corks, generally I think they re-cork those bottles every 10 years. A 40-year-old cork is way too long. Most of the wine that's produced, 98% of the wine that's produced is meant to be drunk within the first year anyway, so it's usually not that much of a problem. Cork taint has gotten a lot of press in the last decade. And there are varying studies showing the various amounts of cork taint that happens. Estimates from 1% of all wines to somewhere as high as 10% of wines might have cork taint. And much of the blame has been put on this molecule, TCA, or trichloroanisole. And where does that molecule come from? That has this very damp, moldy, unpleasant odor, which we, as humans, can detect that down to 1 part per trillion in the wine. We can detect that. So it's a very prominent if there's even a tiny amount of it in there. And it comes from environmental pollutants. Pollutants on the cork trees. And then there's a fungus which produces that from some of those chlorinated pollutants. This is industrial wood preservatives and things like that. Chlorine bleaching of corks then produces this. And so this is actually a flaw that we introduced through our environmental pollution and industrial processes. There are alternatives. In the 2004, I think, or maybe a little earlier, Hoag Cellars in Washington State did a 3-year study on cork alternatives. Their conclusion from their study was that screw caps are the best for maintaining the quality of the wine, maintaining the color and the flavors, and preventing any kind of problems with taint. But as we know, as we talked about, it doesn't allow the wine to oxidize at all. So there are different aspects that a cork may still be desirable. Synthetic corks, there's the new glass corks, the Zorks, so there are lots of options, crown caps. But I think for the most part, since the problem with trichloroanisole has been discovered, and we know the cause, it's getting less and less likely, I think now, that corks are tainted with that. Corks can have other problems though, and it's not just that molecule which taints everything. Most of the flaws in wine that's due to a cork is often due to corks which weren't sealed well. That's the other problem with natural material. You can have holes, and it can not seal well, and it can oxidize too much. So, I like corks, I'll continue to use them. A few other flaws. Hydrogen sulfide has been mentioned, and the mercaptans that result from that hydrogen sulfide. Acetaldehyde. Acetaldehyde is this sort of sherry, if you've ever had sherry, that's the flavor of acetaldehyde, because sherry is basically wine which has been oxidized. I don't like the acetaldehyde flavor. In other wines besides sherries, you probably don't want that. So it's like oxidation of the ethanol partway to the acetic acid. That can be present there. Ethyl acetate, I mentioned, the geranium smells with sorbate, diacetyl with lactic acid, bacteria, and citric acid. The fusel oils. Fusel oils, this sort of petroleum tasting smells, that's also a winemaking flaw in that there's some ways to control that. Higher temperatures and low nutrients leads to more of those being produced. So controlling fermentation temperature can be important in controlling some of those off flavors. I often get asked, why do we add sulfite? Sulfite is a protective agent for the wine. It kills the weaker natural bacteria, which may not be strong enough to ferment your wine out and give off flavors to your wine. That's why we want to use controlled yeast to ferment our wine to get the optimum result. So often when you crush the grapes, you sulfite it first to kill off some of those weaker natural yeasts before you inoculate it with wine yeasts. We usually add it, particularly as a home winemaker, in the form of potassium metabisulfite. And it's actually sulfur dioxide, which is the protective agent. It's the antioxidant. It's the antibacterial. So it's actually not the bisulfite itself, but bisulfite is in equilibrium with sulfur dioxide. Some large commercial wineries just use gaseous sulfur dioxide and pump it into their barrels to sterilize it or pump it into the wines. This is, by the way, naturally produced during fermentation. About 6 parts per million sulfite, or SO2, is produced during fermentation. Most commercial wines contain up to about 40 parts per million sulfites. US levels that are allowed are actually much higher than that, up to 350 parts per million. You don't want to have too much sulfites. You want just the amount that will be good protective properties, because it can also reduce the color of your wine. If you've added too much sulfites, you might have seen your color be stripped out or it fades, and that's because those anthocyanin coloring molecules are reacted with SO2. So be careful with sulfite. It is SO2, which is the important antibacterial protective agent. We add it in the form of sulfite or bisulfite. This is all an equilibrium process among all these species. They convert back and forth. But where the concentrations of those different components lie depends on the pH of the wine. So wine is typically right here about pH at about 3. So you'll notice this line is the bisulfite concentrations versus the pH. That's bisulfite. At pH 3, this is SO2 concentration. So you really, above pH 4, there's no SO2 in solution. If you go down to 3, then you're up to a certain percentage. Most of it's still tied up as bisulfite, and there's some SO2. Which is good, because you don't want too much SO2, because SO2 also will taste sulfury, too much of it. And so that's actually a pretty good range to be in, close to a pH of 3. But you should know, in order to get the proper levels of SO2, that depends on the pH. And so knowing the pH of the wine is important to decide how much sulfite to add sometimes, if you're really careful about that. So that's a little bit about sulfites. Do sulfites cause headaches? How many people said, I have allergies to the sulfites in wine. I can't drink wines that have been sulfited. And remember, natural fermentation produces some sulfites. So it's going to always be present, even if you haven't sulfited your wine. But actually, I think sulfites have gotten a bad rap, because it's only about 1 in 10,000 people which have an actual allergy to sulfite. And when someone says they're allergic to sulfites in wine, I ask them, well, can you eat raisins without a problem? Or drink grape juice, or any of the dried fruits? They have hundreds of parts per million of sulfites on them. And if they don't have a problem with those, they're not going to have a problem with the 40 part per million sulfite in wine. And so it's not the sulfites in wine which are causing them the problems. It's got to be something else. They might be allergic to something else in the wine, but we can't just blame everything on sulfites. So this idea that we have to make unsulfited wine, it's a bad idea, because your wine will go bad. And it's really not, I think, it's really not causing problems for the general public. So that's all I wanted to talk about. I appreciate you listening to me. I like this quote by Julia Child. Wine is a living liquid. This is not actually true, containing no preservatives. There's natural preservatives in it. But it's a life cycle that comprises youth, maturity, old age, and death. When not treated with reasonable respect, it will sicken and die. And wine is a living liquid. From the moment that grapevine buds out in the spring to in the bottle, it's not done even once you put it in the bottle. It's constantly changing and evolving. And it's a very complicated mix of chemistry. So in wine, there is truth. Thank you very much. I love this picture of Bacchus too. Yeah?
You know, for home winemakers that have oak, is there any, like, how much oak you put in per gallon, how much chips, how long? Should you boil it first, all that stuff?
I wouldn't boil it myself because then you'll remove all those things from the oak. So you've extracted all those flavors out of the oak into the water you're throwing away. In my experience, I've oaked some, and I haven't done a lot of grape wines. I've done mostly fruit wines. I prefer to add oak during fermentation to get the best integration of the oak with the wine. I don't know, you can oak afterwards. Sometimes that doesn't, you can taste that oak, but it's disjointed with the wine unless you let it age for a very long time. I don't know, is there a general rule of thumb of how much oak? It depends on the toast level and what balance, and so what you have to do really is taste it. If you over oak something,
What can you do?
let it sit for a long time.
Invite the friends over.
You know what I would do actually is, if you have a wine which is out of balance, I would find something else to blend